Welcome to the video lecture series on Chemical Engineering Thermodynamics 2. Myself, Jaimin Pandya, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. So let's continue with the chapter number 1, which is the phase equilibria. So in this lecture, we are going to calculate various numerical based on TXY diagram. In previous some lectures, calculate various numerical based on PXY diagram, in which we are assuming value of x from 0 to 1 and then calculate the total pressure using bubble point equation. This total pressure used in Raoult's law and calculate the value of y1. Now in this to plot TXY diagram, in this type of numerical in statement, value of total pressure is given. So we have to put the value of total pressure in Antoine equation and get the value of T1 saturated and T2 saturated. Between this temperature, we have to take a regular interval and take different temperature point so that we can draw TXY diagram. So using that temperature in Antoine equation, again we have to find out P1 saturated and P2 saturated. Using this P1 saturated and P2 saturated and total pressure, we can calculate value of X1, and using this value of X1 in Raoult's law, we can get value of Y1. So we have to use bubble point equation to find out the X1, or instead of this we can also use the dew point calculation to find out the Y1 and put the value of Y1 in Raoult's law and get the value of X1. So there are two methods to find out the X1 and Y1. So we are going to follow this bubble point equation method because it's quite simple than dew point calculation method. So let's calculate this numerical. In statement given that draw the PXY. In statement told that in statement given that prepare TXY diagram at total pressure of 101.33 kilopascal for binary system of benzene and ethyl benzene. Assume Raoult's law is valid for the Antoine equation given. So let's first make the Antoine equation for component 1. Let's suppose benzene is our component 1 and this ethyl benzene is our component 2. So for component 1, this equation becomes P1 saturated is equal to 13.8594 minus 2773.78 upon temperature, which is at T, plus C, which is at 220.07. So it becomes our Antoine equation for component 1. Now let's write for component 2. ln P2S is equal to 14.0045 minus 3279.47 divided by T plus 213.20. Okay, so what we have to do in a statement, total pressure is given. So this Antoine equation can be replaced by like this. So let's first make this Antoine equation for component 1, that can be written like this. ln P is equal to 13.8594 minus 2773.78 divided by T1S plus 220.07. So what we do, this P1 saturated replaced by total pressure and this T replaced by T1 saturated. Okay, similarly for component 2, that can be given by P2S, not P2S, it becomes total P. So ln P is equal to 14.0045 minus 3279.47 upon T2 saturated plus 213.00. Okay, so this becomes our equation number 1, this is our equation number 2, this is our equation number 3, and this is our equation number 4. So using this equation 2 and 3, we can calculate T1 saturated and T2 saturated. So let's first find T1 saturated. So in this equation, if we are going to put the value of pressure is a 101.33 kilopascal, we will get the value of T1 saturated. Similarly, if we are going to put the value of P is a 101.33 kilopascal in this equation number 4, we will get the value of T2 saturated. So value of T1 saturated is a 80.90 degrees Celsius, where value of T2 saturated is a 136.195 degrees Celsius. Okay, so this is a T1 saturated and this is our T2 saturated. To plot the graph of Txy, we need different point of temperature. We can take temperature point lies between T1 saturated and T2 saturated. T1 saturated, which is a 80.90 degrees Celsius, and T2 saturated is a 136.195 degrees Celsius. So we have to take a regular interval between these two temperatures. So let's take temperature is equal to 80.90 degrees Celsius, which is our T1 saturated, then again 91. So we are taking 11 degrees Celsius interval for each temperature. So 80 plus 11, it becomes 91, plus 11, which becomes 102. Then next is a 113, next is a 124, next 136.195 degrees Celsius, which is our T2 temperature, or can say that uh, saturated pressure of ethyl benzene, or saturated temperature of ethyl benzene. Now using this different value of temperature in this Antony equation number 1 and this Antony equation number 3, we can calculate P1 saturated and P2 saturated. So let's first write for this iteration number 1, or can say that taking temperature 80.90 degrees Celsius. So putting this value of temperature in this equation number 1, we will get the value of P1 saturated, that can be given by 101.59 kilopascal. So if we are going to put the value of this T1 saturated as a 80.90 degrees Celsius, so here we are putting 80.90 degrees Celsius instead of this T1 saturated, we will get the value of P1. So here we are going to replace this T with 80.90 degrees Celsius. So we will get the value of P1 saturated, which is a 101.59 kilopascal for this 80.90 degrees Celsius. Again, we have to calculate value of P2 saturated by replacing this T with 80.90 degrees Celsius. Okay, so we will get the value of P2 saturated, which becomes 16.709 kilopascal. So our P2, which becomes 16.709 kilopascal. Now putting this value in a bubble point equation. So what is bubble point equation? Bubble point equation that can be given by P is a, for binary mixture, it becomes x1 P1 saturated plus x2 P2 saturated. We know that x1 plus x2 is equal to 1. So can say that x2 is equal to 1 minus x1. So replacing this x2 with 1 minus x1 in this equation, we will get the P is equal to x1 P1 saturated plus 1 minus x1 to P2 saturated. Simplifying this equation, we will get P is equal to x1 P1 saturated plus P2 saturated minus x1 P2 saturated. So what we do, multiplying this P2 in this bracket. So taking this x1 common from this both term, we will get the x1 is equal to P upon P2s. So taking this P2 to this side, so it becomes P minus P2, and taking x1 common, so it becomes our x1 and P1 minus P2. So P1 minus P2 taking to this side, so it becomes P1 saturated minus P2 saturated. So this becomes our equation number 5. So we are going to use this equation for all these temperature to find out the x1. But this P1 saturated and P2 saturated is different for this all temperature. So if we are going to put the value of P1 saturated and P2 saturated in this equation, we will get the value of x1, which is a 1. Similarly, if we are applying Raoult's law, what is Raoult's law? Raoult's law that can be given by y1 p is equal to x1 p1 saturated. Okay, so by subtracting y1, this equation becomes x1 p1 saturated upon p. So it becomes our equation number 6 to find out the y1. Putting all the value, we will get the value of y1, which is a 1. Okay, so this value of x1 is for the 80 degree point 80.19 degree Celsius. This is value of y1 for the 80.90 degree Celsius. Similarly, we have to find for the different temperature, second temperature, which is 91 degree Celsius. So for T is equal to 91 degree Celsius, what we have to do? First, we have to find P1 saturated and P2 saturated by replacing this T with a 91 degree Celsius. So if we are going to replace this T with 91 degree Celsius, we will get value of P1 saturated, and if we are going to replace value in this second Anthony equation, in this equation number 3, we are going to replace value of temperature with 91 degree Celsius, we will get the value of P2 saturated. So if we are going to calculate this Anthony equation, we will get the value for the P1 saturated and P2 saturated is 140.471 kilopascal, and P2 saturated, which becomes 24.965 kilopascal. Similarly, now using this P1 saturated and P2 saturated in this equation number 5. So this equation number 5, what is equation number 5? X1 is equal to P minus P2 saturated upon P1 saturated minus P2 saturated. So putting this value of P1 and P2 and value of P, which already given in statement. So putting this all value, we can find the value of x1 that can be given by 0.6611, and using this value of x1 in Raoult's law. What is Raoult's law? y1 p is equal to x1 p1 saturated. So making subject of y1, this equation becomes x1 p1 saturated upon p. So this is our equation number 6. Okay, this is our equation number 6. So using this equation number 6, we can find the value of y1 by putting value of this x1 and this p1. So we will get the value of y1 is a 0.9164. Similarly, we have to calculate for the temperature T is equal to 102 degrees Celsius. So we will get the value of P1 saturated by replacing this temperature with 102 degrees Celsius and this temperature with 102 degrees Celsius. So we will get the value of P1 saturated and P2 saturated. That becomes 190.4653 kilopascal, and P2 is equal to 36.3845 kilopascal. Similarly, using the equation number 5, we will get the value of x1, which is a 0.42294, and y1 becomes 67949. So if we are going to make table for all the different temperature, so if we are going to use this different value of temperature in Antony equation, we will get the P1 saturated and P2 saturated. Using this value of P1 saturated and P2 saturated in equation number 5, we will get the value of x1, and using this value of x1 in equation number 6, we will get value of y1. So at different temperature we are calculating this all the stuff and get this table. Now if we are going to plot the graph of this xy, it should look like this. So how to plot this graph? So first take good range between these temperatures, so we can plot the graph. So we are starting from 60, no need to starting from 0, because we will get good visualization by plotting with 60. So taking 10 interval of each temperature 60, 70, 80 on y axis for the temperature, and this on x axis we have mole fraction of liquid component and mole fraction of vapor component, which is a xy, which lies from 0 to 1. So first we have to draw the xt diagram. So let's take value of x is a 1. So this is the value of x is equal to 1. At 1, temperature is a 80.09. So it's near about 80.09. So this is our 80.09. Okay. So this becomes our xt. Similarly, for x1 is equal to 0.66. So at 0.66 is near about like this. Okay, and value of temperature is a 91, so it becomes this point. Again, if we are going to take the value of x, which is a 0.40, so it becomes like this, and temperature is a 102. Similarly, for 0.42 it becomes like this. So we will get this type of point, and connecting this point we will get this type of curve. So it becomes our Tx curve. Okay. Now we have to draw Ty curve. For Ty curve, again take the value of y1, which is a 1. So it becomes same point, because 1 and the temperature value is 80.09, which is the same as the x1. So we will get same point. Then y1, which is on 0.91. So we will get this type of point. For y2, 0.79, we will get this type of point at temperature 102. For 61, so this y is a 0.61, which near about like this. So this is our 0.61, and temperature 113 degrees Celsius. And for the 0.37, so here we will get the near about 0.37 and temperature 124. So by connecting these all the points, we will get the curve like this. So it becomes our Ty curve. Okay, Tx curve, which known as a bubble point curve, and Ty curve, which known as a dew point curve. Below the bubble point curve there is a liquid solution, and above the dew point curve there will be a vapor, and between dew point and bubble point we will get the liquid plus vapor equilibrium with each other. So this is how we can draw the Txy diagram. So this is all about today's lecture. I am completing my lecture here. Thank you.